Now, Gauss's law is an important law in electrostatics which deals with electric flux through any closed surface. Over the next few minutes, we will try to understand Gauss's law and each and every terms associated with it. So without wasting any further time, we will directly jump into the topic of Gauss's law. The statement of Gauss's law is that the total electric flux through any closed surface is 1 upon epsilon naught times the total electric charge enclosed by the surface. I am just going to write the mathematical formula for Gauss's law, which is given by phi E, representing the total electric flux, equals to close integration of E dot ds equals to 1 upon epsilon naught times the total charge enclosed in the surface. So what is the first term we come across? The first term is electric flux. What is electric flux then? Well, electric flux is basically the total number of electric field lines passing through any area normally. What are electric field lines then? Electric field lines are basically the paths traversed by a unit positive charge when placed near any other charge. Meaning, let's say I have a charge plus Q. So if I place another charge plus 1 coulomb here, what will happen to the 1 coulomb charge? If you notice, this source charge is plus Q, this test charge is plus 1. That means both the charges are alike. And what happens when the charges are alike? When charges are alike, then there is repulsion between them. So this plus 1 coulomb charge will surely move away from the plus Q charge, which we are calling as the source charge. So that means this plus 1 coulomb charge will move in this way. Very well. So what will happen if I place plus 1 coulomb charge all around this plus Q charge? What will happen? All of them will travel in these directions. So you see, these are the paths traveled by or traversed by unit positive charge when placed near any other charges. These are called electric field lines, and these electric field lines, when passed through any area normally, what do we mean by normally? Normally means if this is the plane of the area, then the field line should make 90-degree angle with the plane of the area. So let's say if I place any area here, so the total number of electric field lines, these electric field lines which are passing through any area, through this area normally, are called electric field lines and electric flux. So electric flux is given by a formula. What formula? Phi E, we write it as E dot del S. What is E then? E is electric field intensity. Electric field is self-explanatory. You consider any charge, the space around the charge in which if other charges comes, it experiences force, is basically the electric field. You can consider it as the territory of a charge in which if other charges comes, it gets influenced. So that's electric field. Now it's a physical definition. How to mathematically quantify electric field? Well, we have a quantity for that, which is called electric field intensity. Electric field intensity is given by E. How to define electric field intensity then? Well, for that we must know the formula for force between two charges. If you place two charges side by side, let's say I have charge Q1 and Q2, The separation between them, let's say, is R. Then the electrostatic force that exists between these two charges is given by Coulomb's law. So Coulomb's law says that if you have two charges Q1 and Q2 separated by a distance R, then the electrostatic force between these two charges is directly proportional to the product of the charges and inversely proportional to the square of distance between them. If you club them together, we get F proportional to Q1 Q2 by R square. When you remove the proportionality sign, you get a constant K Q1 Q2 by R square. So if we have understood the electrostatic force between two charges, we can define electric field intensity easily. Electric field intensity is defined as the electrostatic force experienced by unit positive charge. So if we have, let's say this example we consider, we have a charge plus Q at the center. We place another charge plus 1 coulomb. Let's say the distance between them is R. So the total force experienced by this plus 1 coulomb charge will be termed as the electric field intensity. So electric field intensity is basically given by the force per unit charge, F by Q. And if we apply this formula, so K is the constant, I am keeping K. Then Q1, for Q1 the central charge is capital Q, so I am writing capital Q. For Q2 the charge is plus 1, capital Q multiplied by 1 is capital Q, so not writing that, divided by R square. So this basically gives the formula for electric field intensity. If you ask what is this R cap, it basically gives the direction of electric field intensity, which is along the direction of electrostatic force. So this formula basically gives us the electric field intensity, which can also be seen in Gauss's law. As you can see, E is electric field intensity. The next thing is del S. What is del S? Del S is area vector. Now that might sound strange to you. Area vector, well, area we have always studied to be scalar quantity. But here we have a quantity called area vector. But how can area have direction? To explain that, if you have area like this, you draw a perpendicular. This perpendicular will give you the direction of area vector. So if the area of this rectangle is del S and a perpendicular on the surface of del S is n cap, then the area vector del S, we denote vector by an arrow overhead, is given by del S into n cap. So you choose any area, you draw a perpendicular. This perpendicular shall give you the direction of area vector. Let's say I have a page. If I keep on placing pages on pages like this, then it moves in the upward direction. That's basically the area vector. So when you multiply E and del S, by the way, E and del S both are vector quantities. So you can multiply vector quantities by special laws. You cannot multiply vectors algebraically like numbers. You cannot treat vectors like numbers. Scalars are numbers. By the way, scalars are those which have only magnitude and vectors have magnitude as well as direction. Also, vectors are added or multiplied by special rules. So these things differentiate vectors from scalars. So E, this is dot, means dot product of del S. The formula for dot product is, if you elaborate, you will get E del S cos of theta. That's basically formula. If you do A dot B, you will get A B cos of theta. Now what is this theta here? Well, theta will obviously be the angle between E and del S. E is direction of electric field. Del S is area vector. So the angle between them is theta. So if you consider this as the area, this is the direction of the electric field and this is the direction of, so I am drawing another perpendicular like this. So if this is the direction of area vector, so the angle between them is basically theta. So the value of electric flux, will depend on the angle theta as well. So if you let's say increase the electric field, the electric flux will get increased. If you increase the area, then also electric flux will get increased. And theta, so it is cos of theta. Now cos theta has maximum value when theta is equal to 0 degree and minimum value when theta is equal to 90 degree. Of course, cos 0 is 1 and cos 90 is 0. So that means if the angle between del S, that means area vector, and E is 0 degree, then the value of electric flux is maximum. And if the angle between E and del S is 90 degree, then the value of phi E, which means the electric flux, is minimum. So that about electric flux. So coming back to our formula for Gauss's law, phi E is electric flux, we have covered, equals to E dot ds. So E is electric field, ds is area vector. Why this integration sign? Because ds is area vector for a very small area, for a fraction of an area. So if you want to have the full area, let's say if you consider a sphere, if you consider a football like this, so this is the total area is, let's say, S. So you take a small fraction, this small fraction is basically ds. Phi E equals to closed integration of E dot ds, which is basically the formula for electric flux. It is equivalent to 1 by epsilon naught into Q. So what is epsilon naught? Epsilon naught is called the permittivity of free space. Permittivity of free space. And permittivity of free space, we get this from this formula also. This formula, if you recall, is Coulomb's law. That means the force which exists between two charges. Now, F, right here just, F equals to K Q1 Q2 by R square. K can be written as 1 by 4 pi epsilon naught Q1 Q2 by R square. So K basically means 1 by 4 pi epsilon naught. 4 pi is obviously number and epsilon naught is the absolute permittivity. Absolute permittivity. What it is? See, permittivity basically means that how easily electric field can pass through any medium. Absolute permittivity means how easily electric field can pass through air or vacuum. For any material, it will be epsilon. For vacuum, it will be epsilon naught. Now, permittivity basically represents the ability of a medium to permit electric field. Does it have any value? Of course it has. This value of K is 9 into 10 to the power 9 Newton meter square per Coulomb square. Newton is of course the SI unit of force, meter is the SI unit of distance, and Coulomb is the SI unit of charge. Epsilon naught value is 8.854 into 10 to the power minus 12. You see, K is equal to 1 upon 4 pi epsilon naught. So whatever the unit of K, epsilon naught will have a reciprocal of that unit. For example, it is Newton meter square per Coulomb square. What is the power on Newton? It is 1. So for epsilon naught, it will be negative 1. What is the power on meter? It is plus 2. So here it will be minus 2. What is the power on Coulomb? minus 2. So now it will be plus 2. That's the reciprocity I was talking about. So the value of epsilon naught is 8.854 into 10 to the power minus 12. We can say coulomb square per Newton per meter square for simplicity, or you can say per Newton per meter square coulomb square. That's also correct. If you want to use Gauss's law in any numerical problem or in any situation, you got to remember the value of epsilon naught, which is absolute permittivity, and it is very crucial and essential to remember it, because without epsilon naught we cannot figure out the total electric flux. So that was about Gauss's law. Now to sum it up, Gauss's law statement we have already discussed. It basically gives you the total electric flux. Is there any condition? Yes. The condition for finding Gauss's law is that you got to have a closed surface. That closed surface is basically called the Gaussian surface also. So Gauss's law, what it gives us? It gives us the total electric flux. Total electric flux through which? Through a closed surface. And its value is Q by epsilon naught. Q is the charge enclosed by the surface, and epsilon naught, as we discussed, is the absolute permittivity. What is the significance of Gauss's law? Why we need to learn it? So if you see, if you analyze properly, while discussing electric flux, what I told you, what was the definition we discussed? That electric flux is basically the number of electric field lines passing through any area normally. But isn't that a lengthy process? I mean, you choose an area, you will keep on counting, okay, this one line has passed, 2 line has passed, 3 line has passed. Oh, that's a lengthy, hectic job. Gauss's law, what it magically does for you is, it gives you a shortcut. It gives you a shortcut to find the total electric flux. How? By this very formula. That is, total electric flux is equal to 1 upon epsilon naught times the total electric charge. So now, after knowing Gauss's law, you don't have to count the number of electric field lines and all those hectic jobs. You don't need to do. What you need to do? You just have to know the amount of charge which is enclosed by the surface. If you know the amount of charge, epsilon naught value is a constant, you know it already. So you just need to divide the value of charge with the value of epsilon naught, and you will simply get the total electric flux through a shortcut. So that's Gauss's law for you, and Gauss's law has applications for infinitely straight wire, for plane, sheet, for shell. All of this you have to learn from Gauss's law. So it is an introductory video of Gauss's law where we discussed the concept of Gauss's law and various terminologies associated with it. I hope you got to learn a few things and clear your concepts. Thank you for watching.